For the last part of section 9.5, we're going to look at applications of radical equations. Okay, we're going to look at two applications. The first application deals with what we call pendulums. And I'm going to draw a pendulum here. Let's say that something is hanging by a string, say a metal ball, and it's able to sway from side to side freely. Let's say it's going on this path here, and so it can travel from side to side. That's basically what a pendulum is. If you wanted to write a definition, it's an object that freely hangs from a string. Okay? The thing that connects it to radical equations is its period. And when I say its period, I'm talking about the time it takes for the pendulum to go from one extreme to the other. Okay? And when I mean by extremes, I mean if it sways as far right, goes to sway as far left by traveling on that path and then going back, that is the period. The formula for calculating the period of a pendulum is T equals 2 pi times the square root of L over 32. T is the period. It stands for period, or the time it takes to go from one extreme to the other. L is the length of the string. And this pi here is on your calculator. If you look on your calculator, the button for clearing your calculator, right under that is the caret symbol. If you do second and then that caret symbol, you'll have pi, which is approximately 3.14. Okay? So what we're going to do is use this formula to help us find either the period, or we can actually solve this for the length of the string that pendulum is on. Let's look at a couple of examples. Our first example here, it says a pendulum has a length of 5 feet. Find its period rounded to the nearest hundredth of a foot. Note that they give us the length, which is L, for our formula. So I'm going to use my formula, T equals 2 pi times the square root of L over 32. And notice you won't have to remember this formula. I will give it to you. I just want you to be able to use it. If we want to find the period, let's put 5 in for L. So that's going to be 2 pi times the square root of 5 over 32. This can be put in your calculator. Remember, when you put it in the calculator, that pi is actually 3.14, or you can use the actual value for pi by doing second and then your caret symbol. Once you do that, you're going to see that in your calculator you get the following answer. 2.483, so on and so forth. Notice that I only have to round it to the nearest hundred, so I only need 2 decimal places, which is 2.48 seconds. So it takes that pendulum 2.48 seconds to go from both extremes and back. Let's look at another example. It says a pendulum has a period. Remember, I have a period of 1.8 seconds. Period is T. Find its length in feet, round to the nearest tenth of a foot. Okay, I'm going to write down my formula, and then I'm going to try to work this out. T equals 2 pi times the square root of L over 32. This time, since I've given a period, I got to put 1.8 in for T. So now I have to solve for L. Well, in order for me to solve for L, I've got to isolate that radical. because L is under that square root. So I need to get rid of that square root. That's my problem. So what I'm going to do is I'm going to have to get rid of that 2 pi first. So let's divide both sides by 2 pi. When I divide both sides by 2 pi, those cancel. And I'm going to get the square root of L over 32 on my right-hand side. And my left-hand side is still going to be that 1.8 over 2 pi. Now that I have the radical isolated, I'm going to raise both sides to the second power. And notice that I left that 1.8 over 2 pi as it is. Okay. On my right-hand side, I'll still have my L over 32. The square root is going to cancel with that second power. And now I need to distribute that 2 squared to the numerator and the denominator. Once I do that, let's scroll up a little. I am going to figure out what these things squared are. 1.8 squared is 3.24. Notice I have to distribute this exponent to the inside of that parentheses. 2 squared is 4, and I'm going to leave pi as pi squared. Okay. Now I'm going to put this left-hand side into my calculator. But when I put it in the calculator, I'm going to make sure that I put my denominator in parentheses. Okay, so I'm going to have 3.24 divided by parentheses 4 times pi. Do your caret symbol so you can have the exponent 2 raised to the second power. Okay. Once you do that calculation in your calculator, you should have 0.08207, so on and so forth, equals L over 32. All right. And the only reason why I didn't go write that whole decimal out is because I only have to round to the nearest tenth, right? And so I just stopped at the 5th digit. It doesn't really matter. You can go to the 4th. Now that I want to solve for L, I want to multiply both sides by 32. And that way the 32s will cancel and I have L completely by itself. 32 times 0.08207 is, it's approximately 2.62624, which if I round it to the nearest 10th place, 2.6, and in units it would be feet, because my length of my pendulum string is in feet. Now we're going to look at one other example that doesn't have anything to do with a pendulum, but it does have to do with sort of giving a formula of things dealing with square roots. It says the speed s that a vehicle was traveling in miles per hour can be approximated by the formula s equals the square root of 30 df, where d represents the length of the skid marks in feet and f represents the drag factor. A vehicle involved in an accident made 145 feet of skid marks before crashing. If the drag factor for the road is 0.08, find the speed of the car that the car was traveling. All right, well, we're going to use the formula S equals the square root of 30 times D times F. Okay, it told us that the car was traveling, it made a skid mark of 145 feet. Okay, 145 feet is the length of the skid marks. That's D. So we have square root of 30 times 145. And the drag factor of the road that it was traveling on is 0.8. And so if I want to know the speed of the car, I can put this in my calculator. If I put it in my calculator, I'm going to get that my speed is 58.99152 miles per hour, which is approximately 59 miles per hour. This concludes this section, and here is your homework.